Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 2 Motion in One Dimension. We will be discussing the topic Acceleration and Graphical Representation of Linear Motion. Hope you all are ready for the session. Let's begin. We have discussed what is distance travel, displacement, what is the difference between them, speed and velocity. Now we'll understand what is acceleration. So when a car is moving, we know that the velocity or the speed will be changing, right? It's not always a uniform speed. At some times, that is in a busy market. You imagine you are in a busy market, you're driving your car. What happens there? There you will have to change the speed. At some times you will have to bring the car to rest. When there is traffic, what you will be doing? You will be reducing the speed. When it is an empty road, what you do? You will be accelerating the car and the car will be moving at a high speed, right? So at different instances, your speed or the velocity will be different. Yes, so this is what acceleration is. That is the rate of change of velocity we call acceleration. Acceleration is the rate of change of velocity. Okay. Now, what is the unit of acceleration? We have said that acceleration is rate of change of velocity. That is with respect to time, what is the change in velocity? We can say that acceleration, which is represented by small letter a, is equal to velocity change divided by time. Okay, when there is divided by time, it means there is a rate of change with respect to time. What is the change in velocity is what acceleration is. Okay, what is velocity? Velocity is equal to displacement by time. What is the unit of velocity we have studied? Displacement, the unit is meter, and for time the unit is second. So, velocity unit is meter per second or meter second inverse. Okay, now we need to find the unit of acceleration, velocity by time. What is the unit of velocity? Meter per second. So, unit of acceleration is velocity meter per second divided by time second. That is equal to meter per second square or ms raised to minus 2. So, this is the unit of acceleration. Retardation. We have said that when the velocity of an object, velocity of a car increases, the body is said to be in acceleration. That is, you are accelerating a car. Okay. Now, when the body's velocity is decreasing, that is, velocity of body is decreasing, that is, you are applying brakes. What happens? Velocity will be decreasing, right? So, then we call that the body is said to be retarded. There is deceleration or negative acceleration. In simple words, retardation is negative acceleration. Okay, that is, you can just imagine this example. You are applying brakes and bringing a car to rest. There what happens? The velocity is decreasing. Then the body is said to be decelerating. Clear? We have said that velocity depends on both direction and magnitude. Velocity is a vector quantity and it has magnitude and direction. So, acceleration is also a vector quantity. It has both magnitude and direction. When you consider a one-dimension motion, in a one-dimension motion, that is motion along a straight line. If a body is moving, okay, this body is moving. When this body is moving in one direction, we can say that the distance travelled and displacement will be the same. Yes, because here the motion is along a straight line. Now, when you take the case of acceleration and retardation, we can say that when velocity is increasing, for example, initially at time 1 second, the velocity is 2 meter per second. 2 seconds, 4 meter per second. 3 seconds, 6 meter per second. And 4 seconds, 8 meter per second. So, in this case, you can see that when time increases, what is happening to velocity? Velocity is also increasing. So, this case is an example of acceleration. Acceleration with increase in time, there is increase in velocity as well. Okay. Now, 1 second, the velocity is 8 meter per second. 2 seconds, the velocity becomes 6 meter per second. 3 seconds, the velocity becomes 4 meter per second, and 4 seconds the velocity becomes 2 meter per second. So here what you can see, with increase in time, when time increases, velocity is decreasing, which means there is negative acceleration or retardation. Clear? Relation for acceleration. Now consider that a body is moving initially with a velocity, initial velocity u meter per second. Okay, after some times, let's say after t seconds, its velocity, which we call the final velocity, is v meter per second. Then we can find the acceleration. What is acceleration? Acceleration is equal to, acceleration represented with letter A is equal to change in velocity by time. Okay, what is change in velocity? Change in velocity is final velocity minus initial velocity. Okay, this is change in velocity divided by time. So here in t seconds, initial velocity u becomes final velocity v, which is equal to v minus u divided by t. So this is the relation. Acceleration A is equal to v minus u by t. If you are asked to find the final velocity when acceleration, initial velocity and time is known, then how to find the final velocity? Here we can write v minus u is equal to a into t. Okay, I am taking this t to the opposite side. Or v is equal to minus u taken to the opposite side becomes plus u plus at. Okay, v is equal to u plus at. So this is how you can find the final velocity. Now, if a body is starting from rest means the initial velocity will become equal to 0. Okay, in that case, what is acceleration? Acceleration will be equal to final velocity divided by time. Okay, velocity by time will give you the acceleration. Understood? Let us take an example. A car is initially at rest. On starting, acquires a velocity of 20 meter per second in 10 seconds. What is the acceleration of the car? Here, the car is initially at rest. Therefore, initial velocity u is equal to 0. Okay. It acquires a velocity of 20 meter per second, which means final velocity v is equal to 20 meter per second in 10 seconds. Time t is equal to 10 seconds. What is the acceleration of the car? Acceleration A, we have the relation A is equal to v minus u divided by t. So this is the relation. Okay, now substitute the values. A is equal to 20 minus 0 divided by 10, which is equal to 20 by 10 equal to 2 meter per second square. So this is the unit of acceleration. Unit is very important. 2 meter per second square. Okay, second example, a car initially moving with a velocity 25 meter per second is brought to rest in 5 seconds by applying the brakes. What is the acceleration of the car? Here, initial velocity u. Initial velocity u is equal to 25 meter per second. Is brought to rest in 5 seconds. So, time t is equal to 5 seconds. It is brought to rest, which means the final velocity will be 0. Final velocity v is equal to 0. So, we need to find the acceleration. Acceleration is equal to v minus u divided by t. Put the values. A is equal to 0 minus 25 divided by 5, which is equal to minus 5 meter per second square. Okay, acceleration. So, this is the case of retardation, deceleration or negative acceleration. So, here when you write acceleration, you should put this negative sign, or you can say retardation. Retardation is equal to 5 meter per second square. Okay. So, when you write retardation, negative sign is not required, but when you write acceleration, it should be having the negative sign. Okay. Uniform and non-uniform acceleration. We have studied uniform and non-uniform velocity. Yes, so what will be uniform acceleration and non-uniform acceleration? So when you take a case where time and velocity are, the data is collected with time and velocity. Okay, 1 seconds, 2 meter per second, 2 seconds, 4 meter per second, 3 seconds, 6 meter per second, 4 seconds, 8 meter per second. Okay, for different time, the different velocities are noted. So you can see that here with increase in time, there is increase in velocity as well. Yes, when you find the acceleration, first 1 second, let's take. So this case, okay, here 1 second to 2 seconds, the time is considered as 1 second. That is, acceleration will be equal to change in velocity 4 minus 2 divided by change in time 2 minus 1, which is equal to 4 minus 2, 2 by 1, which is 2 meter per second square. So here for the first 1 second, the acceleration is 2 meter per second square. Now the second, let us consider 2 seconds to 3 seconds. Time taken is 1 second. What about change in velocity? Final velocity is 6 meter per second and initial velocity is 4 meter per second. So change is 2 meter per second. 2 meter per second divided by 1 second, which will be again equal to 2 meter per second square. Acceleration is 2 meter per second square. Take the third case, 3 seconds to 4 seconds. Time gap is 1 second. 6 meter per second is initial velocity, 8 meter per second is final velocity. Change in velocity will be 8 minus 6, which is equal to 2 meter per second. Then acceleration will be 2 meter per second divided by 1 second, which is again 2 meter per second square. So in all these three cases, we are getting the same value for acceleration. So this is an example of uniform acceleration. Okay, with increase in time, there is increase in velocity. Yes, velocity is directly proportional to time in this case. When time increases, velocity also increases at a fixed rate. That is, at a constant value for acceleration is what we are getting. Next, non-uniform acceleration. Just the opposite, that is, with change in time, the change in velocity need not be constant. Okay, that is, when you take an example, time velocity data, 1 second, 2 second, 3 seconds, 4 seconds. So first 1 second, the velocity is 2 meter per second. 2 second, the velocity is 0 meter per second. 3 seconds, the velocity becomes 8 meter per second. 4th second, the velocity is minus 2 meter per second. Okay, now when you find the acceleration, so here acceleration will be 1 second to 2 seconds, the change in time is 1 second. 0 minus 2, which is minus 2. So minus 2 meter per second square. Okay, here with increase in time, there is decrease in velocity, therefore deceleration. Okay, next 2 seconds to 3 seconds, again the time is 1 second, 8 minus 0, which is 8. Okay, so 8 meter per second square is the acceleration. Next, when you take the third part, 3 seconds to 4 seconds, 1 second again, minus 2 minus 8, which is equal to minus 10. So minus 10 meter per second square. So you can see that the value of acceleration is different. Here it is minus 2 meter per second square, here it is 8 meter per second square, and here it is minus 10 meter per second square. So with respect to time, there is change in velocity, but it is not uniform. Okay, this is an example of non-uniform acceleration. If the velocity of an object increases or decreases by unequal amounts in equal interval of time. Here it is equal amounts in equal intervals of time. Okay, so unequal amounts in equal intervals of time, then the object is said to be in non-uniform acceleration. Here the interval of time that we are taking in both these cases is 1 second. Okay, acceleration due to gravity. When you release an object from your hand, what happens? It will fall to the ground. So what is the reason? Because the earth pulls it to the ground. There is a gravitational force of attraction. The acceleration produced in a body due to the gravitational force is called the acceleration due to gravity. Acceleration due to gravity we represent by the letter G, and the unit is meter per second square. There is a value for G. Okay, now when I am releasing this pen, what happens? It falls to the ground. What is happening actually? Its velocity is increasing at a rate of 9.8 meter per second square. And this value of g is the acceleration of the body. Okay, so initially in 1 second what happens is its velocity will become 9.8 meter per second. When the time becomes 2 seconds, the velocity of the body will become 19.6 meter per second. That is 2 into 9.8. Okay. Third second, it will become 29.4 meter per second. 4 seconds, it becomes 39.2 meter per second. 5 seconds, it becomes 49 meter per second. Okay, now when you find the acceleration, so when you take this interval, what is acceleration? Acceleration will be equal to final velocity 9.6 minus initial velocity 9.8 divided by time 1 second. Change in time, 2 seconds minus 1 second, so 1 second. This is equal to 9.8 meter per second square. So here we are getting acceleration to be equal to 9.8 meter per second square. Now take this interval. What do we get? Acceleration will be equal to 29.4 minus 19.6 divided by change in time again 1 second. This is again equal to 9.8 meter per second square. So when you find the values in this interval again, A will be 9.8 meter per second square. Here again A will be equal to 9.8 meter per second square. So when you take a 1 second time, you can see that the rate of change of velocity or the acceleration is 9.8 meters per second square. So this is the case of a freely falling body. Okay, and the value is same. Now, what about you are throwing an object upwards? So, when I am throwing this pen upwards, so you can see that it will go to a point and then come to stop. After that, it will fall down, right? So, here what is happening to velocity? So, when I throw a pen upwards, initially I am applying a force. There will be some velocity. Let's say initially, the first second, its velocity is 49 meter per second. This velocity, what happens? It will be decreasing and it will become 0 is a point where it is at rest, after which it will be coming down. So 2 seconds, it becomes 39.2 meter per second. 3 seconds, it becomes 29.4 meter per second. 4 seconds, it becomes 19.6 meter per second. 5 seconds it becomes 9.8 meter per second, and the 6th second it comes to rest, 0 meter per second. So when you find the acceleration in this case, what do we get? First interval you are taking, you are finding the acceleration. So this will be equal to 39.2 minus 49 divided by 1 second. This is equal to minus 9.8 meter per second square. So here when you consider all these intervals, you will be getting the value to be minus 9.8 meter per second square. Okay, so acceleration is negative. This is an example of retardation, deceleration or negative acceleration. Okay, so here the value of acceleration will be minus g. Okay, minus g, and the value of g we know is 9.8 meter per second square. Understood? So when a body is freely falling down and the body that is released upwards, when it is thrown upwards. So what is happening, you have understood, right? Example 3, a pebble thrown vertically upwards with an initial velocity 50 meter per second comes to a stop in 5 seconds. Find the retardation. So we have initial velocity. Initial velocity is equal to, u is equal to 50 meter per second. It finally comes to rest. Therefore, final velocity will be, final velocity v is equal to 0. Time t is equal to 5 seconds. We need to find the retardation. What is acceleration? Acceleration is equal to v minus u divided by t. Here 0 minus 50 divided by 5 equal to minus 50 by 5 equal to minus 10 meter per second square. Okay. Minus 10 meter per second square is the acceleration, which means the retardation is equal to 10 meter per second square. Okay, 10 meter per second square is the retardation. So here we are considering a body that is moving in a straight line path, rectilinear path, linear motion or motion in one dimension. So this motion in one dimension can be easily analyzed using three important graphs. One is displacement time graphs. As the name suggests, you will be having on one axis the position or displacement, and on the other axis you will be having time. Okay, then velocity time graph, velocity on one axis and time on the other axis. Next is acceleration time graph. So in detail we are going to study about all these three graphs. First is displacement time graph. In case of displacement time graph, you will be having the x-axis and y-axis. So time in seconds will be taken along the x-axis, and along the y-axis you will be having displacement or position. This is also called position time graph. So displacement in meters will be taken along y-axis. For example, let's take some data, time and position. So time in seconds and position in meters. So initially a body starts, okay, it reaches in 1 second at 2 meter distance. Okay, from origin it is at 2 meter distance in 1 second. So in 2 seconds it becomes 4 meter, 3 seconds 6 meter, 4 seconds 8 meter, and 5 seconds 10 meter. So how do we plot this on the graph? You will have to consider some points. So here along the time axis I will be taking 1, 2, 3, 4, 5. Okay. Now the position 2, 4, 6, 8, 10. All these are in meters. So first 1 second 2 meter. 1 second 2 meter. This is a point. 2 seconds 4 meter. This point 3 seconds 6 meter. This point 4 seconds 8 meter. 4 seconds 8 meter. 5 seconds 10 meter. Okay. When you join these points, you will get a straight line. So here you can see that with increase in time, the displacement is also increasing. Okay. Now if you can find the velocity, it will be easier, right? From the graph you can find the velocity. So what is velocity? Velocity is change in position by change in time, or displacement by time. So here what you are going to do is you are going to take the slope. Now how to take the slope? So here, okay, I have considered 2 points, let's say A and B. To get the slope, okay, I will be considering this right triangle. So in this interval, then we will be drawing normals. Okay. Now you need to get the slope. So slope will be equal to, here I am considering this as C. Slope will be equal to BC divided by AC. Here BC is B. When you draw the normal, here it is 6 meters. So 6 meters minus, this is 2 meters divided by AC. AC 3 seconds minus 1 second. So this is equal to 4 meter per 2 seconds, which is 2 meter per second. You can see that this is a positive value. So here we are getting a positive slope. Positive slope, and this is a velocity of the moving body. Okay. Now if you are getting a graph such that, for example, this is your graph. Okay. This is your graph. When do we get this type of a graph? This type of a graph is obtained. Like initially it was at 8 meters, that is the body is moving towards the origin. Here you can see that from origin it is at 2 meter, then 4 meter, that is it is moving away from the origin. If the body is moving towards the origin, in that case what happens? Yes, so initially it was the first second, for 0 seconds it was at 8 meters, 1 second it becomes at 6 meters, 2 seconds it becomes at 4 meters. So here what is happening? The displacement is decreasing. The value of displacement is decreasing. Then you will be getting a slope which is of this manner, and this is called a negative slope. In that case, velocity is going to be negative. So, we will be discussing this in detail. Just understand this. Time is taken along the x-axis and the displacement is taken along the y-axis in case of a displacement time graph or a position time graph. Also, the slope of the graph will give you the velocity. First case is if the position of a body does not change with time. Okay, so here at 0 seconds, at 1 second, 2 seconds, 3 seconds and 4 seconds, we are noting the values of displacement. Okay, here it is given that the position does not change, which means initially let's say it was at 2 meters. After 1 second, it is at 2 meter. After 2 seconds again, it is at 2 meter. 3 seconds, 2 meter. 4 seconds, 2 meter. That is, you can see that the position is not changing. Here, along the x-axis, you will be taking the time in seconds. Along the y-axis, you will be taking the position in meters. Okay, so here 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds. Okay, 1 meter, 2 meter, 3 meter, 4 meters and 5 meters. So, first point, at 0 seconds, the body is at a distance of 2 meters from the origin. So, 0 seconds, 2 meters. 1 second, 2 meters. 2 seconds, 2 meters. 3 seconds, 2 meters. 4 seconds, 2 meters. In this case, you can see that when you join these points, you are getting a straight line. Okay, straight line parallel to x-axis or the time axis. So, when you plot a displacement time graph for a body whose position does not change with time, you will be getting a straight line that is parallel to the time axis. So, instead of 2 meter, if it was at 5 meters, then how do we get? At 5 meters, 0 seconds, it is at 5 meter, 1 second 5 meter, 2 seconds 5 meter, 3 seconds 5 meter, 4 seconds 5 meters, 5 seconds 5 meters, 6 seconds 5 meter. Then you will be having a line. Okay, this line is also parallel to the x-axis. Okay, so this is the first graph that we have studied. Second case, if a body is moving with uniform velocity. What is uniform velocity? Velocity remains constant. So, for 0 second, let's take some data. 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. So, displacement, initially it is at the origin, 0 meter, then 10 meter, 20 meter, 30 meter, 40 meters. So, here we are taking time along the x-axis, time in seconds, and along the y-axis, the position or the displacement. Both are same. So, displacement in meters. So, 1 second, 2 second, 3 second, 4 second, 5 seconds. So, here 10 meter, 20 meter, 30 meter, 40 meter, 50 meters. Okay, for 1 second, what is happening? The displacement becomes 10 meter, a distance of 10 meter from the origin. So, this point, 2 seconds, 20 meter, 3 seconds, 30 meter, 4 seconds, 40 meter, 5 seconds, 50 meter. So, you will be getting, when you join these points, you will be getting a straight line. And this straight line is at an angle to the x-axis or time axis. It is inclined to the x-axis. Okay. So, initially you got this thing. This is a slope and the slope of this graph will give you the velocity. Let's take slope. So, I am considering this here A point, B point, C point. Okay. So, slope will be equal to AC by BC. AC by BC. Here what is AC? AC is equal to 40 meter minus 20 meter divided by BC is equal to 4 seconds minus 2 seconds. 4 seconds minus 2 seconds, which is equal to 20 meter by 2 seconds, that is 10 meter per second. So here we are getting slope is equal to 10, which means the velocity is 10 meter per second. Now, we'll take another set of data. For 0 seconds, it is at 0 meter. 1 second, this is at 12 meter. 2 seconds, 24 meter. 3 seconds, 36 meter. 4 seconds, 48 meters. Okay, mark the points. 1 second, 12. 2 seconds, 24. 3 seconds, 36. 4 seconds, 48. Okay, now join these. So when you join these, again you are getting a straight line that is inclined to the x-axis. So now you need to take the slope. Okay, I am going to take the slope in this case. So here we'll consider this part and we are going to find the slope. So what will be the slope? Slope is equal to ABC we have taken D, E, F. What is D, F, D? D marking is at 36. 36 minus F marking is at 12. 12 divided by. Here EF. To take EF, F is at 3 seconds and E is at 1 second. So this is equal to 36 minus 12, which is 24 divided by 2 seconds, 24 meter by 2 seconds, which is equal to 12 meter per second. So here when you take the slope, the velocity we are getting, which is 12 meter per second. So what do you understand from this? 12 meter per second. The slope is increasing. The slope, that is the inclination is increasing. When inclination is increasing, velocity also is increasing. Velocity is a constant value, but still it is increasing. So when slope increases, you can say when slope increases, velocity also increases. Okay. Now, another set of data at 0 seconds, this is at 0 meter. At 1 seconds, the body is at 5 meters. 2 seconds, 10 meter. 3 seconds, 15 meter. And 4 seconds, 20 meters. Plot the values. 1 second, 5 meters. So here, 2 seconds, 10. 3 seconds, 15. 4 seconds, 20, 5 seconds, it will be 25. Okay. Now, when you join these points, you will again get a straight line which is inclined to the x-axis. When you take the slope, so let's find the slope in this case. So, to find slope, I am considering this portion. Okay. D, E, F, G, H, I. So, here the slope will be equal to GI divided by HI. GI, G is 15 and I 5. 15 minus 5 divided by 3 seconds, 1 second. So, 3 minus 1, which is equal to 10 by 2. It is 5 meter per second. So, here you can see that the slope has decreased and the velocity has also decreased. So, initially the velocity, we got 10 meter per second for this slope, blue slope. Okay. Then, red one, we got with increased slope, increased velocity. Green, decreased slope, decreased velocity. Now, I'll ask you a question. Okay. Can you get this type of a graph? That is a straight line that is parallel to the y-axis. Do we get this type? What does it mean? Here you will be having 6 seconds. Initially, at 6 seconds, the body is at 0 meter. At 6 seconds, body is at 10 meter. At 6 seconds, body is at 20 meter. At 6 seconds, the body is at 30 meter. 6 seconds, body is at 40 meter. 6 seconds, body is at 50 meter. Is this possible? time is not changing, but the displacement is changing. Is it possible? We know that we cannot stop time. Yes, if a body is not moving, then the displacement you will be getting the same value. But time will always be changing. So this type of a graph is not possible. That is a straight line. You will never get a displacement time graph with a straight line that is parallel to the displacement axis or the time axis. So we have also discussed about the negative slope. So if you are having a set of data such that initially it is at 50 meter at 0 seconds, then 1 second the body is at 40 meter, 2 seconds the body is at 30 meter, 4 seconds, 3 seconds the body is at 20 meter, 4 seconds the body is at 10 meter. So when you plot, how do we get? So 50 meters at 0 seconds, initially this position. Then 1 second, 40 meter, 2 seconds, 30 meter, 3 seconds, 20 meter, 4 seconds, 10 meter. Okay, then you will be getting this type of a straight line. Only difference is, again here you are getting negative slope. You will be getting negative slope. That is the only difference, because when you find the velocity value what you get will be negative. Because here there is a decrease in the displacement values. Okay. Third case, if a body is moving with varying speed in a fixed direction, that is considered in the case of non-uniform velocity, time and displacement. So here let's take some data. 0 seconds, 0 meters, 2 seconds, 10 meters, 5 seconds, 30 meters, 6 seconds, 47 meters, 7 seconds, 62 meters. Okay, now we can plot here along the x-axis taking time in seconds, along the y-axis taking displacement in meters. So 1 second, 2 second, 3 second, 4, 5, 6, 7, 8, 9, 10. Okay. Now here we will be taking 10 meter, 20 meter, 30 meters, 40 meters, 50 meters, 60 meters, 70 meters. So first 0 seconds, 0 meter origin, 2 seconds, 10 meters, 2 seconds, 10 meter. Here you will be getting 5 seconds, 30 meters, 5 seconds, 30 meters, 6 seconds, 47, 6 seconds, 47 is somewhere here. 7 seconds, 62. 7 seconds, 62 here. So when you join these points, you will be getting not a straight line, but this is a curve. Okay, you are getting a curve. Now, if you want to find the velocity, so this is the graph for non-uniform velocity. Okay, non-uniform motion. Here, if you need to get the graph, you will be considering any point on this curve and then draw a tangent. Okay, so here I am considering this point and I am drawing the tangent. Now we are going to find the slope of this tangent. Okay, to find the slope, I will be considering here A, B, C. Okay, so slope will give you the velocity at that instant. So slope will be equal to AC divided by BC. Here AC is equal to 40 meter minus 10 meter divided by BC, 6 seconds minus 3 seconds. So this is equal to 40 minus 10, 30 meters divided by 3 seconds, which is equal to 10 meter per second. So this is the velocity. Okay, when you find the slope, you will be getting the velocity. So this is the curve that is obtained for non-uniform motion. Okay, non-uniform motion. So here again one more thing, if you are here, you can see that the velocity, that is the displacement, is increasing, right? Now if the case is here you had 62 meter, then 47 meters, then 30 meters, 10 meters, 0 meters, that is the body is moving towards the origin. In that case what happens, you will be getting a curve such that this is how the curve will be. Okay, and you will get negative slope. So here when the displacement is decreasing, that is the body is moving towards the origin. In that case, with time, when you plot the graph, you will be getting this type of a curve. Clear? Next is velocity time graph. In case of displacement time graph or position time graph, time is taken along the x-axis and the displacement is taken along y-axis. Now, similarly, in case of a velocity time graph, you will be taking the time along x-axis and now the velocity is taken along the y-axis. Unit is meter per second. So, we know that the velocity is equal to displacement divided by time. So, you will be having positive velocity and negative velocity. Why? Because velocity is a vector quantity. If a body is moving away from the origin, in that case, you will be getting positive velocity. A body is moving towards the origin, you will be getting negative velocity. Okay. Now, velocity, as we said, it has both magnitude and as well as direction. So, using a velocity time graph, when you plot a velocity time graph, I will show you how to plot velocity time graph in different cases. When you plot a velocity time graph, using the velocity time graph, you can find two things. One is the displacement. Okay, one is displacement, and in a given interval, what is the displacement you can find using velocity time graph, and the second is the acceleration at a particular instant of time. Okay. In an interval, you can find displacement and acceleration at a particular instant of time you can find using a velocity time graph. We will discuss in detail how to find this. Displacement from velocity time sketch. Okay, the area enclosed between the velocity time sketch and the x-axis will give you the displacement of the body. Okay, so let's take some data. Time and velocity. So, initially 0 seconds, 0 meter per second, 1 second, 1 meter per second, 2 seconds, 2 meter per second, 3 seconds, 3 meter per second, 4 seconds, 0, 5 seconds, minus 3 meter per second, 6 seconds, minus 3 meter per second, 7 seconds, minus 3 meter per second, 8 seconds, minus 3 meter per second, 9 seconds, 0, 10 seconds, 3 meter per second, 11 seconds, again 3 meter per second, 12 seconds, 3 meter per second, 13 seconds, again 0. Okay, now let us plot this. So, here in case of a velocity time graph, time in seconds is taken along the x-axis. 1 second, 2 second, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So, here we have both positive and negative velocity. Okay, this is a positive, this is a negative part. Now, here you have 1 meter per second. This is velocity in meter per seconds. 2, 3, minus 1, minus 2, minus 3. For 0, 0 origin. 1 seconds, 1 meter per second. 2, 2 meter per second. 3, 3 meter per second. For 4, it is 0. 5, minus 3. So, here 6 again minus 3, 7 minus 3, 8 minus 3, then 9, again 0, 10, it is 3, 11, 3, 12, 3, 13, 0. So, when you join these points, you will be getting the velocity time sketch. Okay, so I am joining all these, I am getting the velocity time sketch. So, here you can see that you are having two trapeziums and a triangle. We know to find the area of triangle, we know to find the area of trapezium. So, you can get the displacement. So, what is the total area enclosed? What is the total area? First, you will have to consider this triangle. Okay. For a triangle, the area is half into base into height. Plus, you have trapezium 1 and trapezium 2. For trapezium, what is it? You will be having half into sum of the parallel sides. Sum of parallel sides into height. Okay. Again, plus half into sum of parallel sides into height. This is for second trapezium, this is for first trapezium. Okay. So, here we have half into base. Base is 4 and height is 3. Okay. Now you have to consider when you are finding displacement. While taking area, what you have to consider is to find the displacement, you have to consider the positive and negative part. Okay. So plus half into sum of parallel. So here what are the parallel sides? So here you have 4 to 9. 9 minus 4 which is 5. Okay. Into 5 plus. What about this? So here 8 and here 5. So 8 minus 5 that is 3. Into height. What is the height in this case? Here the height is minus 3. Okay. So minus 3. Plus next trapezium is above the origin. Therefore positive itself, half into sum of the parallel sides. So here 13 minus 9 is 4. 12 minus 10 is 2. 4 plus 2 which is 6. Into what is the height? Positive 3. Okay, so how much do we get? Cancelling here it is 2. So 6 plus 8 by 2, 4. 4 into minus 3 that is minus 12 plus this is 3. 3 into 3, 9. So 6 plus 9, 6 plus 9 you will be getting 15. 15 minus 12 which is 3. So here we are getting the displacement to be 3 meters. The area is 3 and the displacement will be 3 meters. Okay. Now if you are finding the distance, in case you are finding the distance, then you don't need to consider the negative sign. Okay, negative sign you can remove. So you will be getting this part. This part is 6. This minus 12 becomes plus 12 and here we have 9 plus 9. So 12 plus 9, 21 plus 6 that is 27. The distance will be equal to 27. So this is how you will be finding. So how to find acceleration from velocity time graph? We know that we can get the velocity from a displacement time graph by finding the slope. Similarly, here to get the acceleration, you need to find the slope of the graph. So here, initially we'll find slope of this one. Okay, this part. Okay, let's name this as AB. How to find the slope? Here slope will be equal to this point. So this is 3 minus 0 divided by. So here you will be getting the part. Okay, 3 minus 0 divided by here again 3 minus 0 which is equal to 3 meter per second square. For this part, this is a gradient or slope, you will be getting 3 meter per second square. For this part, the acceleration is 3 meter per second square. Now consider this portion, that is B. Let's name this as C and this is D. Okay, BD. Slope of BD we are going to find. Slope of BD will be equal to, so here what is the value? D. So you have to get for BD, D value, we know it is minus 3, minus here it is 3, divided by time change. So 5 seconds and this is 3 seconds, 5 minus 3 which is equal to minus 6 divided by 2 equal to minus 3 meter per second square. You can see this is a case of retardation, velocity is decreasing. Okay, now next. When you take this portion, let us name this as E. Okay, slope of DE. How to get the slope? How do we get the slope? You can see that there is no change in velocity. That is minus 3. Here also minus 3. So minus 3. This point, for this point it is minus 3 and for this point also it is minus 3. Minus 3. What is the time change? Here it is 8 seconds and here it is 5 seconds. So 8 minus 5 which is 3. So here you will get minus 3 plus 3 which is 0. So 0 meter per second square. Here there is no acceleration. Okay, acceleration is 0 meter per second square. Now this portion, let's name this as FG. Okay, slope of EG. What is the slope of EG? How much do we get here? You can see that the velocity is increasing. Yes, so this will be equal to, here this point you will be having 3 minus of minus 3. At point E it is minus 3 divided by time change 10 seconds and this is 8 seconds minus 8, which is equal to 3 plus 3, 6 by 2 equal to 3 meter per second square. 3 meter per second square. Now what about this region? That is GH. What is the slope of GH? Slope of GH will be 0 because velocity is not changing with time. When there is no change in velocity, we know that the slope will be 0, the acceleration will be 0. Next, this portion, the last portion, that is HI. Slope HI will be equal to, here the velocity becomes 0 and H point velocity is 3 divided by time change 13 minus 12, which is equal to minus 3 by 1 equal to minus 3 meter per second square. Retardation, here the velocity is decreasing. So this is how you can find the acceleration from a velocity time graph. Case 1, if a body is in motion with a uniform velocity, the velocity time graph is a straight line parallel to the time axis. So here for 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, the velocity is same. Let's say the velocity is 4 meter per second at 0 seconds. At 1 second again 4 meter per second. 2 seconds 4 meter per second. 3 seconds 4 meter per second. 4 seconds again 4 meter per second. Okay. Now when you plot the graph along the x-axis, we are taking time in seconds. Along the y-axis, we are taking velocity in meter per second. Now the values 1 second, 2 second, 3 second, 4 second, 5 seconds. Here 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second. Initially 0, here we have origin at 0 seconds. The velocity is 4 meter per second, 1 second 4 meter per second, 2 seconds 4 meter per second, 3 seconds 4 meter per second, 4 seconds 4 meter per second. So when you join these points, you will be getting a straight line that is parallel to the time axis. Okay. Now if you are asked to find the displacement, you will have to find the area enclosed by the velocity time sketch and the x-axis. So this is the area. Okay, here what will be the area? This is a rectangle. So area is length into breadth. Length is this portion and breadth is this portion. Okay, so here if you are considering A, B, C, D. Okay, AB into BC will give you the area, which is the displacement. What is AB? AB is 4 minus 0, 4 into BC. BC is 4 minus 0 again, so 4, which is 16. So 4 seconds into 4 meter per second, right? 4 seconds into 4 meter per second. Seconds can be cancelled, you will be getting 16 meters. So this is the displacement. Displacement is the area enclosed between the velocity time sketch and the x-axis. Okay. Second case, if the body is in motion with uniform acceleration, the velocity time graph is a straight line inclined to the time axis. The slope of line gives acceleration. So here, let's take some data. 0 second, 1 second, 2 seconds, 3 seconds, 4 seconds. So 0 seconds, 0, 10 meter per second for 1 second, 2 seconds, 20 meter per second, 3 seconds, 30 meter per second, and 4 seconds, 40 meter per second. So when you plot the graph, so here you have the time in seconds and here you have the velocity in meter per second. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So here 1, 2, 10, 20, 30, 40, 50, 60. Okay, now plot the points 0, 0, 1 second, 10, 2 seconds, 20, 3 seconds, 30, 4 seconds, 40. So when you join these points, you are getting a straight line that is inclined to the time axis. Similar graph you have obtained before. Where was it? When you drew the displacement time graph for uniform velocity. So here it is uniform acceleration. Okay. Now if you need to find the displacement from this, what will be the displacement? Displacement is the area enclosed. So how to get the area enclosed? You will have to join this Okay, so we are going to find what this area is. Area of a right triangle, which is equal to half into base into height. Here the base is 4 seconds and the height is 40 meter per second, which is equal to 80 meters. So the displacement is 80 meters. Okay, now how to find acceleration? We know acceleration is slope. Acceleration is slope. So consider some region. So this region I am considering A, B, C. Okay, so acceleration to get this will be equal to slope, which is equal to AC by BC. What is AC? AC will be 40 minus 20. 40 minus 20 divided by BC is 4 seconds minus 2 seconds. 4 minus 2, which is equal to 20 by 2 equal to 10 meter per second square. So 10 meter per second square is the acceleration. Case 2, this is a case of retardation, that is the velocity is decreasing. So here 0 second, 1 second, 2 seconds, 3 seconds, 4 seconds. The velocity is 40 meter per second, 30 meter per second, 20 meter per second, 10 meter per second and 0. Okay. Now taking along the y-axis time in seconds, along the x-axis velocity in meter per second. So 1 second, 2, 3, 4, 5, 10, 20, 30, 40, 50. So here 0, it is 40, 1, 30 meter per second, 2, 20, 3, 10 meter per second, 4, 0. When you join these points, you will be getting a straight line that is inclined to the x-axis with a negative slope. Okay, so slope will be negative. So here, what is the slope? Now I am taking this region. Slope will be AB divided by BC. AB will be 30 minus 10, which is 20, divided by BC is 3 minus 1, 2. We get 10. So negative 10. Why? Because this is a case of retardation. Velocity is decreasing and the slope will be negative. Negative slope will be taken. So minus 10 meter per second square will be the acceleration. Acceleration is the slope of the graph. Okay, acceleration will be minus 10 meter per second square. Okay, now the slope will be increasing when you have different values, depending on the values. Okay, so when slope increases, what happens? Acceleration will also increase. Slope increases, acceleration increases. Similar case we have discussed in detail. Okay, when the slope increases, inclination increases, the velocity will be increasing. Velocity, that is the slope of the displacement time graph increases, velocity increases. So when the slope of velocity time graph increases, the acceleration increases. Okay, next, time is not changing, velocity is changing. For example, 1 second, 1 second, 1 second, 1 second, 1 second. The velocity is 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second, 10 meter per second. So when you plot the graph by taking time along the x-axis, velocity along y-axis in meter per second. So for the 1 second, 1, 2, 3, 4, 5. 1 second you have different velocities, 2, 4, 6, 8, 10. So these are the 5 points. When you join, you will be getting a straight line which is parallel to the y-axis. So is this possible? No, right? This is not possible. Why? The time will always be changing. You cannot stop time. Without changing time, changing velocity is never going to be possible. So this case will not exist. That is, we won't get a velocity time graph with a straight line that is parallel to the velocity axis or y-axis. Similar case we have discussed, we won't get a displacement time graph with a straight line that is parallel to the displacement axis or the y-axis. Okay, similar case this is, because here you have to remember time will always be changing. So the velocity time graph can never be a straight line parallel to the velocity axis or y-axis. Next is if the body is initially moving with some constant velocity and then it accelerates. So initially at 0 seconds the body was moving at 10 meter per second. 1 second it become 15 meter per second. 2 seconds 20 meter per second. 3 seconds 25 meter per second, 4 seconds, 30 meter per second. Okay, so when you plot the graph, so here you have time and here you have velocity in meter per second. So time in seconds. So 1, 2, 3, 4, 5. 10 velocities, 5, 10, 15, 20, 25, 30, 35. So for 1 second, 0 seconds, it is 10 meter per second. So starting from here, okay, 1 second, 15, 2 seconds, 20, 3 seconds, 25, 4 seconds, 30. Okay. Now when you draw a straight line, the only difference is before we got the slope such that it started from the origin. So here it will be just starting from 10 meter per second. Okay. Now, in order to find the displacement, we need to find the area. So, while finding the area, you will have to find the area of this entire region. So, here you are having a triangle and you have a rectangle. Okay. So, area of triangle plus area of rectangle, or this is then the shape of a trapezium. Yes, you can find the area of this trapezium. Okay, so first we'll find the area of the triangle. Area of triangle is half into base into height plus length into breadth. That is the area of this rectangle. Half into, what is the base here? 10. Here we have this point 10. So this is 0 to 4. Okay, so the base will be 4 into, what is the height? 30 minus 10, which is equal to 20, plus area of this rectangle. Length is 4 and breadth is 10. So this is equal to 2. So you will be getting final answer 80. 2 into 20, which is 40. 4 into 10, 40, 40 plus 40, 80. So, displacement will be equal to 80. So, if you are finding with the area of trapezium, what is area of trapezium? Half into sum of the parallel sides. So, here these are the parallel sides. Here we have 30 and here we have 10. So, 30 plus 10 into height. Here the height is 4. So, cancelling, we get 2. So, 40 into 2, which is 80. So, either you can find the area of the trapezium or separately the area of rectangle plus area of triangle. You will be getting the displacement. Now, how to get the acceleration? Acceleration is slope. Here, what is the slope? If you consider this portion, okay, this entire portion I am considering, we'll name it as ABC. So, the slope will be AC divided by BC. Here, AC will be, AC is equal to 30 minus 10, which is 20 divided by BC is 4 minus 0, which is 4, equal to 5 meter per second square. So, this is the acceleration. Clear? Now, consider the motion of a body that is released from a height. So, when a body is released from height, it will touch the ground. When it touches the ground, it has acquired maximum velocity. That is, the body is accelerating. There is acceleration due to gravity. So, when a ball or a body is released, initially the velocity will be equal to 0. It will have maximum velocity when it touches the ground. So, after touching the ground, what happens? It will bounce back. Okay, and bounce back to the same height, and there again the velocity will become 0. First, you will be having two motions. One is the downward motion and the second is upward motion. Downward motion and upward motion. So, for downward motion, let's say at time 0 seconds, the velocity is 0 meter per second. When the time becomes 5 seconds, it has acquired the maximum velocity and reached the ground. And here, the velocity is 50 meter per second. Okay, so here the downward motion is complete. Now it is the upward motion. The upward motion. So at 5 seconds we are starting. 5 seconds it has having a velocity. Now you should remember one thing. Now it is moving in the opposite direction. So there you will be taking the velocity to be minus 50 meter per second. Okay, in 10 seconds what happens is the velocity will become 0. That is, it has reached the maximum height. So when you plot these, okay, you have both positive and negative velocities. Time is taken along the y-axis and velocity is taken along the x-axis. Okay, so here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then you have velocity. Here we have 50 meter per second and this is minus 50 meter per second. Okay, initially 0 seconds the velocity is 0 meter per second. In 5 seconds it becomes 50 meter per second. So 50 meter per second. So this point. Okay, next in 5 seconds upward motion, when we consider, the velocity is minus 50. This point. Okay, then in 10 seconds it becomes 0. So this is the. Okay, so this is the graph. This is for downward motion and this is for upward motion. So upward motion, we are having the velocity is decreasing. This is a case of retardation. Here during the downward motion the velocity is increasing. This is a case of acceleration. So when you take the slope, this slope will be negative because this is retardation, and for downward motion you will be getting the positive slope. You just need to find the slope. So here slope during the downward motion, slope will be equal to, so I am considering this region, slope will be equal to 5. We take this as ABC, AC by BC. Here AC is equal to 50 minus 0, which is 50, divided by BC is 5 minus 0, 5. Therefore, 10 meter per second square. Okay, when you take the slope, this slope you will be getting minus 10 meter per second square. For upward motion, the slope will be equal to minus 10 meter per second square. So the acceleration in this case will be minus 10 meter per second square, or retardation will be 10 meter per second square. By now we have studied displacement time graph and the velocity time graph. So we know how to plot the graph. So what will be acceleration time graph? In case of an acceleration time graph, along the x-axis you will be taking time in seconds, and along the y-axis you will be taking acceleration in meter per second square. Okay, so this gives you a acceleration time graph. Okay, first case, if the body is stationary or if it is moving with uniform velocity, the acceleration is 0 in that case. So here consider for 0 second, 1 second, 2 seconds, 3 seconds and 4 seconds. Let's say the velocity is 20 meter per second, 20 meter per second, 20 meter per second, 20 meter per second, 20 meter per second. Even if the body is not moving, in that case velocity will be 0. That is one case. And the second case is when the velocity is the same value, uniform velocity. What will be the acceleration? Acceleration is change in velocity by time. So here what will be the change in velocity? Velocity is not changing. So acceleration in all these cases will be equal to 0. So when you plot a graph for time along x-axis and acceleration along y-axis in meter per second square, how much do you get? So here you have 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Here let's say acceleration 0, 2, 4, 6, 8, 10. Okay, so for 0 seconds acceleration is 0. For 1 second, the acceleration is 0, 2 seconds acceleration 0, 3 seconds acceleration 0 and 4 second acceleration 0, which means you are getting a straight line that is coinciding with x-axis. Okay, that is overlapping the x-axis. So when the velocity is a constant, uniform velocity, or the body is not moving, the acceleration time graph will be a straight line that is coinciding with the time axis. Second case, if the velocity of a body in motion increases uniformly with time. For example, time 0, 1, 2, 3, 4. The velocity is 20 meter per second, 40 meter per second, 60 meter per second, 80 meter per second, 100 meter per second. What is the acceleration? Acceleration is change in velocity by time. So here 40 minus 20. 40 minus 20 is 20. 20 divided by 1 second, which is 20. So here you get 20 meter per second square. Next, 60 minus, when you take this part, 60 minus 40 is again 20. 20 by 1, 20. 20 meter per second square. So when you calculate all these, you will be getting the same value, that is 20 meter per second square. Okay, now plotting the graph, time taken along the x-axis, acceleration along y-axis. So what are the values? Here for 1 second, 2 seconds, 3 seconds, 4 seconds, the acceleration is same, that is 20. So here you have 20, this is 40, this is 60, this is 80. So same value, 1 seconds 20, 0 20, 2 20, 3 seconds 20, 4 seconds 20. You are getting a line that is parallel to the time axis or x-axis. So when you plot an acceleration time graph for a body whose velocity is increasing uniformly, you will be getting a straight line that is parallel to the time axis or x-axis. Third case, if the velocity of a body decreases at a constant rate, the retardation is constant. So here again 0, 1, 2, 3, 4 velocities 80 meter per second, 60 meter per second, 40 meter per second, 20 meter per second, 0 meter per second. You can see that the velocity is decreasing. Now what is the acceleration? Final velocity minus initial velocity divided by time. So here 60 minus 80. 60 minus 80 is minus 20 divided by change in time 1. So minus 20 meter per second square. When you find all these, you will be getting the same value, minus 20 meter per second square, 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 which means that retardation is 20 meter per second square or acceleration is minus 20 meter per second square, a constant value. When you plot the graph, here you need negative acceleration. Time is taken along the x-axis and acceleration is taken along the y-axis. Okay, so 1 second, 2, 3, 4, 5. Here you have 20 acceleration 20 meter per second square. Here you have minus 20 meter per second square. So different values. 1 second minus 20, 2 second minus 20, 3 second minus 20, 4 second minus 20. So you will be getting a straight line that is below the x-axis and is parallel to the x-axis. Okay, this is a case of retardation. Next, the fourth case, if the velocity of a body changes in an irregular manner, the acceleration is variable, the acceleration time graph will be a curve. It can be of any shape, that is depending on the data. For example, 0, 1, 2, 3, 4. Let's say velocity is 20 meter per second, then 10 meter per second, then 35 meter per second, then 50 meter per second, 58 meter per second. Okay, so what is the acceleration? So 10 minus 20, 10 minus 20 is minus 10, minus 10 divided by 1, you get minus 10. So here minus 10 meter per second square. Now the second one, 35 minus 10. What is 35 minus 10? 35 minus 10 is equal to 25, 25 by 1, so 25 meter per second square. Next is 50 minus 35 is 15, 15 meter per second square. 58 minus 50 is 8, 8 meter per second square. Okay, so these are the acceleration values. So you can see that this acceleration values are not a constant. So here when you plot a graph, so this is (10, 20, 30, 40) acceleration taken in meter per second square. So here you have the y-axis, negative direction, 10, 20, 30, 40. Okay, now time in seconds. 1 second, 2 second, 3 second, 4 second, 5 second. So first, for the first interval 1 second, here initially you will be having 0. Then you have minus 10 meter per second square. So this is minus 10. Okay, these are the negative values. Minus 10. So here second, 2 seconds, it becomes 25. We are just considering the intervals. 25. Where do we have 25? Here you will be having 25. Next 15. So here you will be having 15. Next 8. Here you will be having 8. So here you can see this is how the curve looks like. Okay, so you are getting a curve. Okay, this is the acceleration time graph when the velocity is not uniform or it is not increasing uniformly. Let us now study the acceleration time graph for a body's motion under gravity. We know that when a body is dropped, what happens? Its velocity increases. Velocity increases at a rate of 9.8 meter per second square. We have studied the acceleration will be equal to 9.8 meter per second square during the downward motion, and during the upward motion it will be, acceleration will be minus 9.8 meter per second square. So here what happens? Initially when the body is dropped, the velocity is increasing at this rate 9.8. It will be, velocity will become 9.8 in 1 second. It will become 19.6 in 2 seconds. It will become 29.4 in 3 seconds and 39.2 in the 4th second. So this is what happens. Okay. Now when you plot a graph, when you take an acceleration time graph, so time, acceleration. Okay. So here you will be seeing that the acceleration value will be a constant which will be 9.8 meter per second square. Time will be changing 1 second, 2 second, 3 second, 4 second, 5 seconds. Okay, the time will be changing, but the acceleration value will always be 9.8 meter per second square. So when you plot an acceleration time graph for a body's motion under gravity, you will be getting a straight line that is parallel to the x-axis or time axis. Okay, so this is acceleration time graph for the same body. Okay, this is for its downward motion. For upward motion, what will be the difference? For upward motion, the graph will be in this way. So time, acceleration. Now the acceleration will be minus 9.8 meter per second square. So when time changes, this is how acceleration will be a constant and the value is minus 9.8 meter per second square. A straight line parallel to the time axis which is below the time axis. Okay, this is for upward motion. Now if you are going to draw the velocity time graph for the same case, when you draw the velocity time graph, we have the data with us. So time and velocity. Okay, when time is 0 seconds, the velocity will be 0 meter per second. That is, the body is kept, that is, the body is not moving. Okay, initially it is at rest. 1 second, it increases to 9.8 meter per second. 2 seconds, it becomes 19.6 meter per second. 3 seconds, it becomes 29.4 meter per second. 4 seconds, it becomes 39.2 meter per second. So this is how it is increasing. When you plot a graph, how will you get the graph? So velocity time graph, when drawn, velocity is taken along the y-axis and time along x-axis. You can see that at the same rate, okay, what is happening? The velocity is increasing with time. So you will be getting this type of a graph. Okay, 1 second 9.8, 2 second 19.6. When you plot, you will be getting this type of a graph, that is a straight line inclined to the time axis. So this is for the downward motion. What about upward motion? Upward motion, what happens? 0 seconds. So initially you will be having the 49 meter per second. For 1 second it will become 39.2. 2 seconds it will become 29.4. 3 seconds 19.6. At equal rate, what is happening here? There is a decrease in velocity. So we will be getting the velocity time graph for the upward motion. Here this is a case of retardation. You will be getting a straight line with a negative slope which is inclined to the x-axis or time axis. Okay, so this is an example of uniformly accelerated motion, and the upward motion is an example of uniformly retarded motion. Okay, you can also draw the displacement time graph for the same. So when you plot the displacement time graph when plotted for the downward motion, you will be getting this type of a curve. Okay, and time is along y-axis, x-axis, and the displacement is along the y-axis. So for the upward motion, this is how it is. Okay. For a motion of a body under gravity, you can draw the acceleration time graph, the velocity time graph, and the displacement time graph. Clear? That's all for today. In today's class, we have studied about acceleration and retardation. We have also studied the graphical representation of motion. We have studied displacement time graph, velocity time graph, and acceleration time graph. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.